Avoidance. Hello everyone. Our team's topic is collision avoidance systems in cars. The following are the members of our team: Rima Raj, Riya Saini, myself Somali, and Devanshu. The major concern of an engineer should be firstly safety, because it concerns the use of his or her inventions and the accompanying dangers due to human limitations. When it comes to the use of a motor vehicle, accidents have occurred over years, telling us that something needs to be done about them from an engineering point of view. So, collision avoidance systems is an automobile safety system designed to reduce the severity of collision. It is also known as pre-crash system, forward collision warning system, or mitigating system. It basically uses an ultrasonic sensor for the purpose of detecting obstacles, also an Arduino microcontroller or any such microcontroller which can control and which can interface the sensor and other components, and also very essentially a motor driver board which drives the motor, so that the motor can be interfaced with the microcontroller so that the speed of the motor can be controlled according to whatever the code we are putting in. Once the detection is done, the system is either provides a warning to the driver when there is an imminent collision or action, or take action autonomously without any driver input. So basically, collision doesn't mean collision between two cars, but also between a car and any other obstacle which may be present on the road. So, at times when the reaction time of the human brain is not so accurate, such devices help us in preventing a collision, which can be very dangerous and harmful to life. And the rest of the components will be explained by my teammates. Thank you.
Hello everybody, I'm Rima Raj, and now I'm going to discuss about the two major components of our project. The first being ultrasonic sensors. So here, as we see, this is an ultrasonic sensor. It consists of one transmitting transducer and one receiving transducer. It basically has 4 pins: VCC, which is connected to a voltage supply of 3 to 5 volts. Then a trigger, which is connected to the digital pin of Arduino. The third is echo, which is used to calculate the distance between the object and the sensor. The fourth is grounded. Here we see the working of an ultrasonic sensor. The transmitting transducer sends a signal which, when encountered by an object, gets reflected back to the receiver, and by calculating the air density and the speed and the timing, we calculate the distance between the sensor and the object. The second major device is motor driver shield L293D. Here we see its IC, which is 16-pin IC. Here we can see that there are 4 inputs and 4 outputs. Motor driver shield is used for connecting and driving stepper motor, servo motor, and DC motor. There are 2 enable pins in the IC, which is connected to 5 volts, and 1 VCC, which is again connected to 5 volts. There's 1 VSS, which is connected to the power supply. 4, 5th, 12th and 13th pins are grounded here. Okay, now we discuss the uses of IC L293D. It helps in maximizing the number of pins. It expands the 3 pin of Arduino to 8 pins. It also controls the direction, helps in controlling the direction of motor. It also increases the maximum current, and as we have discussed, it helps in driving stepper motor, DC motor, and servo motors. Applications of ultrasonic sensors: it helps in counting application. It helps in measuring the height, the depth, the distance between 2 objects, and the position and location, etc. Here we see the basic application of ultrasonic sensors in a car. Here it's helping the car to know about its distance between the object and the car during parking, so that it has safe parking without any accident or collision. So these were the 2 major devices that we have used in our project. Thank you.
Hello everyone, my name is Devanshu Mukherjee and today I will be explaining about the Arduino controller, microcontroller board that we have used in our project. As you can see here is the photo, the top view of the Arduino microcontroller board. I will explain about the components in the further slides. So moving on, this is the label diagram of the Arduino board. It is known as the Arduino Uno board. The most important components are the microcontroller, the IC here, port pins, the USB plug and the external power supply. So moving on, the Arduino microcontroller, the Arduino board uses a microcontroller of 80 mega 328p. This is from the Atmel company, and this acts as the brain of the Arduino board. Now the program that we have used in our project is dumped onto this microcontroller, and since this acts as the brain, it controls all the other functions and the elements of the board. As you can see here, these are the labels that I have used for explaining the board. Starting from one, that is the power USB. So the Arduino board can be powered by using the cable from your computer. All we have to do is connect the USB cable from the computer USB port and connect it here. Now coming to 2, that is the barrel jack or the external power source. So in case we are not using the USB port here, then we directly use the AC mains and power the Arduino board. Then coming to 3, that is voltage regulator. The function of the voltage regulator is to control the voltage of the Arduino board, and also it stabilizes the DC voltage that is used by the processors and the other elements. Coming to 4, that is the crystal oscillator. The crystal oscillator, as you can see here, that helps the Arduino board in dealing with time issues. Question arises is, how does the Arduino board calculate the time? The answer is by using the crystal oscillator. The number printed on top of the crystal oscillator here is 16.000H9H, which tells us that the maximum frequency that this board can handle is 16 megahertz. Now this Arduino board has two reset buttons that is denoted by 5 and 17 of the diagram, 17 and 5 here. So we can reset the board and start dumping the code again in case we want to make some changes. Now from the diagram, the pins 6, 7, 8 and 9 denote 3.3, 5 ground and VC. So 3.3 volts that is denoted by 6 here is used for supplying 3.3 volts output. 5 volts that is denoted by 7 here is used for supplying 5 volts output. And most of the components on the Arduino board run fine with 3.3 volts and 5 volts. So the pin 8 that is used here is ground, and pin 9 that is used for VIN. So this Arduino board can also be used to power from external sources by using the VIN pin. Now denoted by 10 here is the analog pins. As you can see here, there are 5 analog pins, which is known as A0 to A5. These pins can read signal from an analog source or analog sensor, like the humidity sensor or temperature sensor, and in our case the ultrasonic sensor, and converts it to digital value that can be read by the microprocessor. Now denoted by 13 here is the power LED. So this LED should light up only when you plug in your Arduino device into the power source to indicate that your board is powered up correctly. Now denoted by 14, that is the TX and RX pins here. On your board you will find two labels, that is TX transmit and RX is receive. They appear in two places on the Arduino board. First, the digital pins P0 and P1, that is here, right about these two, and then other is pin 13, that is the TX RX LEDs. The TX LED flashes with different speed while sending serial data, and the speed of the flashing depends on the baud rate used by the board. The RX flashes during the receiving process of the board. Thank you.
I am Ria and I would be discussing the assembly of our model. This, as you can see, is the body of the car, which is also called the chassis. Underneath the chassis, we have connected motors, which is in turn connected to each of the wheels. A 12-volt DC motor is used, and we have also connected batteries separately to power the motors. Now, this is how the assembly looks from the top. The ultrasonic sensor is connected to the front of the car so that the distance of the approaching obstacle is as accurate as it can be. This is the Arduino Uno board, and this is L293 motor driver. L293D syncs the sensor and the motor together along with the help of Arduino. There are uh, two output controls that can be controlled by L293D. One is the forward motion of the motor and one is the backward, which is anti-clockwise and clockwise. So we have two outputs which we have connected to each of the motors for the forward and backward motion. Now this 293D can also be given four inputs. The inputs come from the digital pins 6, 7, 8 and 9 of the Arduino Uno board. The input pins control whether the car is supposed to move forward or backward. The enable pins of the L293D are given a logic high so that both left and right side of the car can function. Now for our project we have initialized the danger distance at around 20 centimeters. So if the distance calculated by the ultrasonic sensor is more than 20 centimeters, that means that the obstacle is more than 20 centimeters away from the car moves straight. That is, both the wheels of the motor are powered high. But if the distance is less than or equal to 20 centimeters, we stop the car for about 1 second and turn the car to the left. So in this case, the left wheel is stopped, that is given a logic no, and the right wheel moves. So this enables the car to turn to the left, and after that, it can start moving forward again.